What I sort of mentioned last time at the very end was that this word normal, it has a different meaning in math. Not just, it doesn't mean usual, okay? The normal line to a curve is the line that is perpendicular to the tangent at that point. So that's key. So if you want the normal at a point, okay, it's perpendicular to the tangent at that point, all right? So here, we're going to have to write an equation for the normal curve to this function at x equals 1, all right? So if we want the equation of the normal curve, and I just said that the normal curve is perpendicular to the tangent line, well, first I need to figure out what the tangent line is, and then it's just a matter of, swapping slopes, right? So let's first find equation of tangent line. Okay? All right, so the slope of the tangent line is the limit as h approaches 0. And it's going to be f of, okay, so it's f of x plus h, right? At what point are we looking for our slope? At x equals 1, so it's going to be f of 1 plus h minus f of 1 all over h. All right? So this is, the limit as h approaches, well, to find the slope of the tangent line, it's always f of x plus h. But if you're given a point where you want to find it, if you want to find it at x equals 1, then instead of f of x plus h, it'll be f of 1 plus h. Just like we did before here. Okay?
Can you get a little bit bigger, please?
Yeah, I'll try.
But every time we do the problem, do we have to write the limit h to the...
Yes.
Yeah, or does it-
Limit, you've got to write it every single time.
Like while you're doing the problem?
Right. All right, so here, this is going to be f of 1 plus h. It's going to be 4 minus 1 plus h squared minus f of 1, which is 4 minus 1 squared, all over h. Oh, sorry. So this is the limit as h approaches 0 of 4 minus 1 minus 2h minus h squared, right? So I did two things at once here. I squared and I distributed the negative. Minus 4 minus 1 squared is just 4 minus 1, which is 3. Okay? All over h. This is equal to the limit as h approaches 0 of, now take a look here, 4 minus 1 minus 3, all go away. What happened to the h's? Let's do the h's. You take 1 out, so what have we got left here?
2 minus h.
Negative 2 minus h. Okay? So the slope is the limit as h approaches 0 of this, and when h does approach 0, what happens to minus 2 minus h? It becomes negative 2. So what did we find then?
The
The
slope.
slope.
The slope of what?
The tangent.
At which point? X equals 1. Okay? So the full answer then is, this is the slope of the tangent line at x equals 1. Okay? So the next time you're at a math party, you want to use like the correct vocabulary. Okay? All right. So if this is the slope of the tangent line, the slope to the normal line,
1 over 2.
right, m equals 1 over 2. All right. Now, To find an equation of a line, I need two things. I need a slope and I need a point. Okay, I have my slope. Do I have a point?
You have an X, you don't have a Y.
I have an X, but I don't have a Y. But if I have an X, can I get the Y? How can I get the Y? Plug it in. X equals 1. Y equals f of 1, which is equal to 4 minus 1 squared, which is 3. So my point is at 1 and 3. Look at that.
Wait, how did you know that y equals f of 1?
Because the point has an x and a y coordinate. If I'm given the x coordinate and I know the function, I can plug it in and get the y coordinate. Okay, so
F of x is equal to f of x equals y.
yeah, yes.
For that f of 1 equals 4 minus 1 squared, would you usually put parentheses around the 1 to show that that's what's being squared? Just because wouldn't it be 9?
You wouldn't put parentheses if it's 4 minus 1 squared like this. You know that the square belongs to the 1. Now, if it was a negative 1, if it was 4 minus negative 1 squared, then I would put parentheses. The way I have it here, that square only belongs to the 1. If it was like this, then it would belong to everybody.
In this case, would we also leave it in standard form?
Right, so point slope form is totally fine. So the normal line is y minus 3 equal to half x minus 1. All right? So if, like in the homework, you have like an A, B, C, where you have to find the slope of the tangent line, and then you have to find the equation of the tangent line, and then you have to find the equation of the normal line, then it's pretty much one process, one procedure, and then it's like boom, boom, boom. Within that, you just found your 3 answers. What would be the equation of the tangent line here?
Y minus 3 equals negative 2 x minus 1.
Okay, yeah. So tangent line, y minus 3 is equal to negative 2 x minus 1. All right?
Is that required for us to put?
No. This particular problem was just asking for the one in red, in the red box. The other one is just for fun. All right. Questions? Did you have a question?
No.
Okay. All right. So let's go back to speed, because what else is there? Okay. All right. So when we were looking at speed in section 2.1, we said that this 16t squared was the equation for a falling object, right? It's the distance that the object fell. Now, those of you that are in physics, that 16t squared, that should be, is it what do you call it? Is it familiar? You probably have the metric version with the 9.8. Okay, so if any,
Negative 9.8. Yeah, gravity is like a square.
right,
Gravity. And
right.
don't take into
So
account errors.
in feet per second, the 9.8 goes away, and then you have a 16 in its place. All right. So back in 2.1, there was a rock that was freely falling. It was falling freely. And we said that y equals 16t squared is the distance according to time. So for example, at t equals 0, the distance is 16, right? At t equals 1, it's 16 times 1. At t equals 2, it's 16 times t squared, and so on. So you know the distance. Okay. Now, we also talked about average speed. Okay? Average speed, we said, was the average rate of change of its position. What does that mean? If you start at one place, you end at another place, how much total time did it take you, right? How much time did it take you for your position to change, for you to go from one place to another? How long did it take you for your position to change from LA to Santa Barbara? How many hours? You divide them, and that's your average speed going there, okay? Now, that's average speed. We also talked about instantaneous speed. And we said the way you found instantaneous speed is by this formula. Okay, where you take f of 2 minus f of 1 over h, but then you have to eventually make h 0. All right, so you look at two different points, but then you bring the points really, really close to each other, and that's your instantaneous speed at that point. So these two, you just have to know. When you're looking for speed on a test, on a quiz, whatever, think to yourself, is it average speed? Is it instantaneous speed? Instantaneous speed is always, at that point, the limit as h approaches 0. Okay? Instantaneous speed means at that point, it's always the limit as h approaches 0. So when you're looking for instantaneous rate of change, that word, instantaneous, you have to think of limit as h approaches 0. Okay? Question?
Yeah, so when you're finding the instantaneous speed, isn't it the exact same thing? Like you're doing the same things except different variables when you're finding something like an equation at one exact point?
Mm-hmm.
Oh,
For instantaneous?
yeah. Like it's that same thing, just the equation has different variables in it. So you're
Correct.
doing the same thing.
Yeah. You're doing the same thing, but like the points that you're picking are really, really close to each other.
Right.
All right. So here it says to find the speed of the falling rock with position function y equals 16t squared at t equals 1 second. So we need to find the speed. Let's think about what we're looking for, because the word instantaneous or average isn't in here. So which is it? We're looking for speed. So here's how I want you to think. You're reading a problem. What am I looking for? Speed. Now, your brain branches off in two directions. It can either be average or instantaneous. In this problem, what do you think we're looking for? Average or instantaneous? Instantaneous, because at t equals 1.
Would the equation be different if it was average?
Yeah, it would be f of 2 minus f of 1 over, yeah. So because it's instantaneous, then the formula is going to be the limit as h approaches 0 of f of 1 plus h minus f of 1 over h.
What's the formula for the average?
F of t2 minus f of t1 over the time. Okay, so now here we're going to have the limit as h approaches 0 of f of 1 plus h, that's 16, 1 plus h squared, minus f of 1, 16 times 1 squared. Okay, you can put the parentheses or you don't have to put the parentheses, they're the same, over h. This is equal to the limit as h approaches 0 of. Okay, I'm going to do two things at the same time here. I'm going to square 1 plus h squared and multiply the 16. So two birds with one stone. So it's 16 plus 32h plus h squared minus 16 over h. And if
shouldn't it be 16h squared?
16h squared, thank you. And if you do it all correctly, what should happen?
Cancel.
Lots of things should cancel out. Okay? So for example, the 16 minus the 16 will go away. And I can also get rid of an h. 1, 1, 1. So I have the limit as h approaches 0 of 32 plus 16h. Okay,
So then you have to plug in h for 0 and 32.
correct. So now, when h is 0, this is equal to 32.
Meters per second?
So, okay,
That's what the speed is?
that's what the speed is. When though?
At 1 second.
At t equals 1 second. Now, you would have to put units. Now, in this problem, we are just given the seconds, not the,
So in units per second.
right, so in units per second, the fact that it's 16, it's in feet. but we don't know that. So it's units per second. Okay? So again, this is the speed at t equals 1. So if the rock is falling, it's not going to stay at the same speed, right? At t equals 1, it's 16, and then eventually, like, it's going to accelerate, right? 9.8 meters per second squared. So it's going to keep increasing and increasing and increasing. All right. So this will be the end of this chapter.